Alright, so today we want to look at how to name acids. So acids are a special class of molecules that we'll spend actually about a month at the end of the year talking about their properties. But let's go ahead and learn how to name them now. That way it'll be one less thing we have to worry about in April or May when we discuss them. So how we recognize acids, for now, we'll discuss more in April or May their characteristics, but for now, if you see a compound that starts with an H, okay, so it starts with hydrogen, it's probably an acid. Okay, we'll assume it's an acid, unless it contains only hydrogen and oxygen. So it can still behave as an acid, but we don't name it as an acid. So like H2O or H2O2, we don't name those as acids. So there are two major types of acids, and each of those major types has its own set of rules. So we'll look first at the binary acids. Okay, so again, the binary acids, kind of like the binary ionic compounds, are just two things. Okay, so it looks like HX. Okay, so H is obviously a hydrogen, and X equals an atom. We'll say, or I'll abbreviate that polyatomic ion that does not contain oxygen. There's really only one example of that, but I want to throw that in there. For the most part, you'll see H plus Cl plus I plus F. Okay, so X is often used to notate a halogen. Okay, so it doesn't necessarily have to be a halogen, but it likely is. So the form for naming binary acids is hydro blank IC acid. So that's the general form for naming binary acids. So the blank is just the root of the name for the X atom here. Okay, so it's just the root of that word. So let's look at HCl. Okay, so I have hydrochlorine. The root of chlorine is just CHLOR. Okay, that is the root of the word ic acid. Okay, so hydrochloric acid, HBr. I have hydro. The root of bromine is just brome, ic acid. Okay, I can have HI. Okay, hydro. Then the root IOD, IC acid. So I capitalized in the middle of these words. That's non-standard to do. I just capitalized it so you could see where the root started there. Okay, so very simple. As long as you know the basic formula here, you just plug in the root of the word there. So let's look at a few in the opposite direction. So I think in your notes you probably have, let me look. Okay, so you have hydrofluoric acid. So if I know if it's hydro something acid, it's just going to be H plus another atom. So hydrofluoric acid is just HF. Okay, so very, very simple to go in the opposite direction. Let's look at the one kind of outlier to binary acids though, HCN. So HCN, cyanide, is a polyatomic that does not contain the oxygen. So that's the one exception kind of this rule. So we call this hydro, the base word of cyanide, cyan, IC acid. Okay, so that's the only really exception to this rule here. For the most part, you'll just have things like HBr, HCl, HI, HF that we'll have to worry about there. And typically they are the halogens, okay? So hydrochloric acid is by far the most common example here. We'll use that very, very much, okay? So go ahead and commit that one to memory, and the rest of them do be able to name though. Notice here for HF, I didn't use any subscripts, I just had one H and one F. The charges do have to balance here. So hydrogen, if you look at the periodic table, has a +1 charge. Fluorine has a -1 charge. If they didn't match up, we would use more than one hydrogen here. We'll look at that in the next example. Okay, but for now, just worry more so about getting the right atoms in the right place. So the other class of atoms we refer to as the acids. We refer to as the oxyacids. Okay, so these look like a hydrogen plus an oxygen containing polyatomic ion. Okay. So there's a nice little chart that we'll write out that shows us the rules for naming these. Okay, so if we have H plus, I'll say the 8, and I'll abbreviate polyatomic ion as poly. So what is an 8 poly? That's like sulfate, phosphate, nitrate. So it's one of the polyatomics that ends in ATE. You name it as blank IC acid. So very similar to above, we don't have the hydro here. Okay? So let's look at H plus the ITE poly. So the ITE poly is always going to be the ATE poly minus 1 oxygen. Okay? So if nitrates NO3, nitrites NO2, if sulfates SO4, sulfite is SO3. So the ITE polys are just the 8 polys minus 1. Okay? The formula for that is blank OUS acid. Then let's look at H plus the hypo ITE acid. Or plus, the hypo ITE poly. So what that looks like, it is the 8 poly minus 2 oxygens. Okay. So if we're looking at sulfate with SO4, up here we would be looking at SO2. Okay, so you just subtract the oxygens. So here our name is hypo, the base, us, acid. Okay. And then down here at the bottom we have H plus the per ATE poly. And what that looks like is you have the ATE plus 1 oxygen. Okay. So it might be easier to memorize let me write how you name it, sorry. So you have per blank ic acid. Okay. So it might be easier to learn this as 8 minus 1 minus 2, 8 plus 1. Okay, or you can flip the chart. Whatever you need to do to learn this chart. It's probably easier to focus on the number of oxygens and use the 8 polyatomic for reference. Okay, and all combinations of atoms won't have all 4 of these. Okay, so we're going to do some examples, and I'm going to write some acids that really don't actually exist, but I'm just going to show you how you would name them if they did exist. Okay, so let's look through the examples in your notes first. So you have HClO, HClO2, HClO3, HClO4. So you always want to name the oxyacids in reference to the 8 polyatomic. Okay, so pick out which one of those is chlorate first. So hopefully you see it is HClO3. Okay, so ClO3 is chlorate. So I go to the 8 polyatomic rule. I just name that chloric acid. Okay. So then the rule, if I have one more oxygen, so the 8 polyatomic plus 1 oxygen is HClO4. So that's the perchlorate polyatomic ion. So this is perchloric acid. Okay. So then I go find the ite polyatomic, HClO2. So that's chlorate minus 1. I have chlorous acid. Okay. And then I have the 8 polyatomic minus 2. So HClO, or that is the hypochlorite polyatomic. So here I have hypochlorous acid. Okay. So notice we name all these in reference to the 8 polyatomic ion there. So let's look at another one. So again, I'm going to make up some acids that likely don't exist, but they just illustrate the point here. So let's say I had HNO4. Okay, so think about what polyatomic ion NO4 is close to, that ends in ATE. So it's nitrate is the corresponding 8 polyatomic. So how do you go from NO3 nitrate to NO4? You have to add 1 oxygen. So I use the naming rule where you add 1 oxygen here. So I would call this per nitric acid. Okay. Or if I had HNO, and that's it, HNO. Okay, nitrates NO3. So to go from NO3 to NO, you have to subtract 2 oxygens. So I name this hypo-nitrous acid. Okay, so these rules are a little bit tricky. Okay, so you have to really memorize these rules right here. Okay, we'll do quite a bit of practice, but you really have to commit these rules to memory in order to get these right. So let's practice a few going from the names to the formulas. So I'm going to write a group of 4, but I won't write them in order. Okay, so I'll write sulfuric acid, I'll write sulfurous acid, and I'll write persulfuric acid, and I'll write hyposulfurous acid. Okay, so first we recognize these are oxyacids because they don't have hydro out in front. Okay, so only the binary acids have hydro out in front. Okay, so the first thing I want to do is I want to locate the 8 polyatomic. So I know an 8 polyatomic corresponds to an acid ending in IC. So I find sulfuric acid. So sulfur, the acidic form of sulfate, is sulfuric acid. So I need to have sulfate, SO4. That is the 8 polyatomic containing sulfur. And I stick an H out in front. But now we need to think about charges. Hydrogen is +1, sulfate's -2. So I need to cross it. H2SO4 there. Okay. And then as you go down, you'll find typically they'll all contain the same number of hydrogens. Okay. So sulfurous acid corresponds to the ITE polyatomic, okay, or the 8 -1. So either you know sulfite is SO3, or you can just do sulfate -1 oxygen. So you have HSO3. You again need to cross the charges and get H2SO3. So persulfuric acid, and again some of these don't exist, I just made this up for illustrative purposes. We would have the sulfate +1, okay, so SO5, okay. So we would name that, or write that H2SO4 if this did exist. It's easier to learn these examples in sets of 4 though than it is to look at individual examples. Then hyposulfurous acid I know is sulfuric acid or sulfate -2 oxygens. Okay, so I have H2SO2. So that's how I name that little family of acids there. Okay, so let's look at 2 more, name it, and then we'll call it quits for acids. These are by far the trickiest, so definitely spend some time committing that the chart for naming the oxyacids to memory. So the first step is to figure out what polyatomic I have. So I have phosphate. So I already have the ATE polyatomic, so I'm in good shape. So phosphate corresponds to phosphoric acid. Okay, so I don't need to worry about the 3. Okay, it's already accounted for there. So phosphoric acid. So then I have phosphite, or phosphate -1 oxygen. So here I would have phosphorus acid. Okay. So notice these names are subtly different, but it changes the formulas. Okay, so it's very important to be very meticulous here and pay close attention to every little letter in the name, because each letter, if it's slightly changed, can mean a completely different acid.